let's look at how to solve a simultaneous equation of three unknown by inverse matrix method. By inverse matrix method. Up to now, we do know how to get the inverse of a 3 by 3 matrix, and we know that a number n multiplied by its inverse gives us 1. So we want to apply that principle so as to be able to solve for the values of the three variables, so the three unknown in a simultaneous equation. So the first step is to obtain a 3 by 3 matrix from the simultaneous equations given. So let's have by taking the coefficients, we shall have 1, 1, 1, 3, negative 4, negative 4, 2, negative 5, 2 as our 3 by 3 matrix. Then this one is multiplied by x, y, and z. So if you multiply all this one, you go back to this simultaneous equation. But all this side is equal to the side negative 17. So this is what we have as our 3 by 3 matrix. So what you do, you get the inverse of this 3 by 3 matrix. And how do you get the determinant, the inverse? By first getting the determinant. So first get the magnitude or the determinant of the 3 by 3 matrix. That is 1, 1, 1, 3, negative 4, negative 4, 2, negative 5, 2. Get the determinant, that is the determinant. By getting the determinant, don't forget the sign arrangement. That is, the sign arrangement is a very, very important factor in 3 by 3 matrices. So you take the 3 by 3 matrix and the sign array for you to be able to get the determinant. That one shall be 1 into negative 4, negative 4, negative 5, 2, then minus 1 into 3, negative 4, 2, 2, then plus 1 into 3, negative 4, 2, negative 5. When you are at this point, you close this row and this column, you end up with this 2 by 2 matrix. When at 2, you close that first row and the middle column, you end up with this and this, this and this. So you just close the row and column where you are for you to be able to get the real matrix of the 2 by 2 matrix that you intend to get. So if you get the magnitude of these 2 by 2 matrices, you shall have, this is negative 8 minus 20, negative 1 into 6 plus 8, and then plus 1 into negative 15 plus 8. This one, if you solve all this one, you shall get negative 49. This one gives you negative 49. So the determinant of this 3 by 3 matrix is negative 49. The determinant is negative 49. The next step for you to be able to proceed so that you'll be able to solve for the inverse, you form what we call a cofactor matrix. So the next step is to form a cofactor matrix. So let's form our cofactor matrix. The cofactor matrix is formed by taking 2 by 2 matrices of each and every point, then multiply by the sign from the sign array. So let's have the 2 by 2 matrix from this one. So the first one, at this point, you start at point 1, you close the row and column, you remain with the 2 by 2 matrix, that is negative 4, negative 4. You remain with negative 5, 2 from your 2 by 2 matrix. You take at this point, you close this row and this column, you remain with this 2 by 2 matrix. So the second one, you start at this point, you close the row and column, you remain with this one and this one, this and this. So you remain with, let's do it, we remain with 3, negative 4, then 2 and 2 as your 2 by 2 matrix. Then the third term, that is 1, you close the row and the column where 1 is, that one you end up with 3, negative 4, 2, negative 5 in that format. Then you come to the middle row, that is at 3, you close this row and the middle column, you need 1, 1, negative 5, negative 2. So that one shall be 1, 1, negative 5, negative 5, 2. Then the second one, that is at point of negative 4, you end up with 1, 1, 2, 2. The third at negative 4, you end up with 1, 1, 2, negative 5. At the linear point, that's at point 2, you close the row and column, you end up with 1, 1, negative 4, negative 4. Then at negative 5, you close the row and column, you end up with 1, 1, 3, negative 4. At point 2, you end up with 1, 1, 3, negative 4 in that format. Then after forming the 2 by 2 arrays, in each bracket you introduce the signs. So the first one, you give its sign. This one is positive, negative, positive, negative, positive, negative, positive, negative, positive. Then you get the magnitude of each and every point. If you get the magnitude of each and every point, you end up with the first bracket cancel. You get that one shall be 2 by negative 4 by 2, that is 8, negative 8 minus 20 with a positive sign at that point. Then at this point you end up with 2 by 1 by 2 is 2, 5 by negative 5 by 1 gives you negative 5. So this is 2 minus 5 becomes plus 5, but you multiply by a negative sign outside. At this point is 2 by 1 by negative 4, that is negative 4. Then negative 4 by this one becomes, then it adds up with a positive sign outside. Then in this column is negative, that is 2 by 3, that is 6. Negative 8, negative and negative becomes positive. Then the positive sign, 2 by 2, 2 by 1 is 2, 2 by 1 is 2, minus 2 in that format. With the negative sign here, 1 by negative 4 is negative 4, 3 by 1 is negative is 3, then minus 3. That format, last row, that is 3 by negative 5, that is negative 15. 2 by negative 4 is negative 4, then the positive and negative gives it a positive sign, and the positive sign outside. Negative into 2 by 1 by negative 5 is negative 5, 2 by 1 is 2, then that's less 2. That format, positive sign outside. In the preceding format, 1 by negative 4 is negative 4, 3 by 1 is 3 minus. So you solve each and bracket for you to be able to form a condensed 3 by 3 matrix. That one shall be, we shall have negative 28 in this one. The second one, that is this one, you end up with negative 14. Then we have this one gives you negative 7. You proceed. This one also gives you negative 7. The middle term gives you 0. That is 2 by 2. This is negative 5 minus 5. That's negative 7 times the positive sign gives you positive 7 outside. Then this one is positive 4 and negative 4 gives you 0. Then this is negative 7 times negative outside gives you positive 7. Then the last term is negative 7. So this is what we call the cofactor matrix. Cofactor matrix. So we need to get what we call the adjoint. To get the adjoint of a 3 by 3 matrix, we transpose to get the adjoint. Transpose to obtain the adjoint. So if you transpose, you change the rows of the and column to get the adjoint. After getting the adjoint, then the inverse of the matrix, inverse is given as 1 over the determinant, 1 over the determinant times the adjoint. So we take 1 over our determinant, that is 1 over negative 49. Then we multiply by the adjoint. To get the adjoint, you take it this way, you maintain the first horizontal column, that one shall be negative 28, then 0, then at here we have got negative 7. That one is maintained. Then you reverse this one and this one. Here it means that negative 14 comes here, negative 17 come here. That's negative 14 here. Here negative 7. Here we have got 0 comes here, negative 7 goes down. So here is negative 7, here we have a 0. And the term, this 7 and 7 crosses term, so it's just 7, 7. So that is our inverse. So this is the inverse of the matrix. So what we do, we take the inverse and multiply both sides. You go to the original equation, multiply both sides by the inverse. That one shall be, you take our inverse, that is 1 over negative 49 into negative 28, negative 7, 0, negative 14, 0, 7, negative 7, 7, 7, negative 7. In that format, you take it in that format, then you multiply by the original matrix which was this side, that is this one, that is 1, 1, 1, 3, negative 4, negative 4, then 2, negative 5, 2, x, y, and z. And whatever you multiply on the left, you also multiply on the right. That is 1 over negative 49 into the matrix, that is negative 28, negative 7, 0, negative 14, 0, 7, then negative 1, 7, negative 7. You multiply by what was on the right, that is 2, negative 1, negative 17. So you multiply both sides. So this one is the inverse of this matrix. Any number, for example, if you have a number n, if you multiply by its inverse, you shall get 1. So this side automatically gives you 1. So it means that this side remains x, y, and z is equal to that other side. That is 1 over negative 49 into negative 28, negative 7, 0, negative 14, 0, 7, negative 7, that is negative 7, this one is 7, negative 7, negative 7, 7, negative 7. In that format, multiplied by 2, negative 1, negative 17. So if you multiply the two, remember how we have done how to multiply 3 by matrices, that is rows and columns. Rows by the column. Then you add them together. X, y, z shall be therefore equal to 1 over negative 49 into, if you multiply all this row and this column and sums together, you get negative. Okay, well, let's just do it together. If you multiply the rows and together, you get negative 28 into 2 plus, that is negative 7 by negative 2, negative 7 by negative 1, then 0 by negative 17 into negative 17. That gives you the upper line. Then the second one shall be negative 14 by negative 2 by 2, sorry, by 2 plus 0 by negative 1 plus 7 by negative 17. Then the last column, that is negative 7 into 2 plus 7 into negative 1, then plus negative 7 into negative 17. So that one shall give you the matrix that we intend to get. That one gives you 1 over negative 49 is equal to the upper one. If you sum, you get negative 49. The middle one, if you sum together, you get negative 147. The down one, if you sum together, you get positive 98. So this one is equal to x, y, and z. So you compare directly, you end up with x is equal to 1 over negative 49 into 49, giving us 1. Y is equal to 1 over negative 49 multiplied by 1, negative 147, giving us 3. And z is equal to 1 over negative 149, 1 into negative 49, sorry, multiplied by 98, giving us negative 2. So we've seen that we can use inverse matrix to solve for the values of the unknown. So we shall stop there till we meet again.